So, well, and welcome back. Very good afternoon to all of you. So, you have started watching video lectures on mathematical foundation of robotics, and in the second unit, we are learning how to model humanoid robot or cobot. Okay, as they are not exactly the same as industrial robot, because to have extra dexterity and other issues, they normally do not follow Piper's recommendation. And as such, getting closed form kinematic solution, like as you know, in terms of E and 2 function, cannot be guaranteed in case of humanoid robot and cobot. So what we are doing, we are exploring the alternative method, and some numerical methods we are actually exploring, because today we have computational muscle power and we would like to use those numerical methods for specifically for solving the inverse pose problem or inverse kinematic problem of humanoid and cobot. Okay, and in that context, we studied already Newton-Raphson method and a variant of the Newton-Raphson method. Let us call it Newton's method. Okay, and now we are going to study another variant of Newton-Raphson method, known as second method. Okay, so this is very simple. Okay, what it does, it replaces tangent line with secant lines. Okay, and one great advantage of this variant of Newton-Raphson method is that here you do not require to compute the derivative of the function at different points, right? And then what is secant, as you know, no? So I am trying to elaborate what is secant by a, say I have a circle or such any other curve, and this is a chord. So chord actually intersect the circle in 2 points, but if I just extend this line in two direction, then it becomes secant. So you can argue what is the difference then? Without this it was chord, and just extension is secant. Yes, there is a difference actually. You see, sorry. So the difference is, say I have a curve like this. Okay, so this is my axis, coordinate axis. So if I just talk about a secant, it may it is extended in this direction and that direction, so it may intersect at several points. Okay, so secant is more general. Okay, so we are talking about secant line. And look carefully, this is, say, my curve. Okay, and at different iteration, say theta n minus 1, theta n plus 1, this function, this is f of theta versus, say, theta. So this function has several values on this iteration points, right? And suppose we know at theta n plus 1, functional value is f of theta n minus 1, and in theta n, functional value is f of theta n, like that. So carefully you see, if I just try to calculate the slope of the secant line, and I am considering this triangle CFB. So, and if this angle is psi, then of course this angle also will be psi, because these are two parallel line. Okay. So tan psi equals to CF divided by BF. So CF, so I know the function, so is equals to CD minus DF, that is function of theta n minus 1 minus theta function of theta n divided by BF. BF is actually theta n minus 1 minus theta n. Okay, so this is tan psi. And consider another triangle BEA, tan psi will be B by AE, that is f of theta n divided by theta n minus theta n plus 1. So this is actually well, let us call it relation 2. Now you see this, we are doing all this thing because practically what we need, we want that to do blah blah something like this, can write the relation like this, so that iteratively we can evaluate the roots of the function, right? So making 1 and 2 equal, then what you have got? You have got functional value of theta n divided by theta n minus theta n plus 1 equals to functional value of theta n minus 1 minus functional value of theta n divided by theta n minus 1 minus theta n. Okay, let us call it 3, and then very simple manipulation we can do, and we can actually get theta n minus theta n plus 1, that is equals to this times this, so this time this divided by this entire expression. So from here I can easily write theta n plus 1 will be actually incremented with earlier theta n value minus, so this I am taking here, this is coming here, so minus sign of this expression, right? So this is actually what, this is nothing but our second algorithm, okay, second algorithm we are calling. So we have got now Newton's algorithm. You can also see, so this is, you see, which is nothing but second derivative and making a function with the second derivative. So f prime theta, which is first derivative of the function f of theta and theta. So if I just do the same thing as Newton-Raphson method we did, right? Let us call it L theta, which is a function which is equals to f prime theta. If I write this, and then you can see tan psi equals to AC by BC, that is first derivative at this point theta 0 divided by delta theta, and then tan psi equals to, because this is a tangent, I can write L prime is first derivative of that function L at theta 0, that is eventually, that is equals to this. So you are getting theta 0 minus theta 1 equals to this, and L prime theta 0 is nothing but, because this is equals to f prime theta 0 and this equals to f double prime, that is double derivative of this, right? And in doing so we are getting, you see, it's very simple, right? So I am writing this in general form like this. In the theta increment in n plus 1 equal will be earlier theta n minus the first derivative of that particular point theta n divided by second derivative of that function at particular point theta n, and we are actually multiplying it by an factor eta. The reason is, you see, now this is called, as in the earlier lecture we have found that this is nothing but Hessian matrix, okay, and when this is a function of several variables, say theta 1, theta 2 up to theta n, then Hessian of this function will be, I have deduced it earlier, n cross n matrix, provided the derivatives exist and they are continuous function. Okay, so that is Hessian. If this is Hessian matrix, then you need to invert that Hessian matrix, and this is equals to grad, that is first derivative of that function. Okay, and in general form, Hessian matrix can be written Hij equals to double derivative of the functional value divided by del theta I del theta j. Okay, so this is great, and you see we are learning all these three variant because they have all of them has some problem and some advantages, some disadvantages, right? So advantages is just like Newton-Raphson, it is returning its quadratic convergence characteristic, but the problem is you need to invert this matrix at each iteration. Okay, that is computationally a little bit expensive because this is of the order of n cube. However, in case of robotic application, n is not that large. 7, 8, 9, 10, those link robot maximum. So this is not great. So we can use it. Okay. But another issue is singularity. So we'll have to check for some configuration. The manipulator or the function may be singular, means the matrix n cross n matrix may not be of full rank, meaning either some row or some column are dependent. Okay, so then the determinant will be 0 and the inversion will not exist. That's why one factor we have given. In those situations, we can make it to 0 so that you can discard those value, and meanwhile you run iteration so that you can come out from those parameters for which the function is the matrix is becoming singular, and then you run the algorithm, right? So these are the two major issues with Newton's algorithm. And Newton-Raphson algorithm, you know, this is Newton-Raphson algorithm also has some problem, although it has quadratic convergence. But if the value for some point, if the value is 0, even approaching to 0, then it's a problem, right? You cannot compute that. And for that, we have kept a factor eta, so that you can come out, and eta has some advantage. Okay, it can be equals to 1, 2, 3, like that, especially for functions which we have discussed earlier. Functions have multiplicity, okay, of the order of 2 or 3, then this is actually those values. If it is multiplicity, if the root has multiplicity 1, then it is multiplied by 1. If it is 2, multiplied by 2, and all kind of thing, right? So that's it. So we have 3 algorithm which I have written: Newton-Raphson algorithm, Newton's, let us call it Newton algorithm. This is nothing but one more differentiation, and this is Hessian matrix. And another algorithm we just derived is called second algorithm. And here you need to make 2 initial guess, and these are the things which are known. Functional value at initial guess theta n will be known. Functional value, okay, at theta n minus 1 will be known. All kind of thing, right? Here we have also added one factor zeta, so that because the convergence issues remains almost same as Newton's algorithm or Newton-Raphson algorithm. So if those issues are there, some value this is approaching to a 0 and all kind of thing, then you need to come out from those situation, right? So eta is for that. But yeah, one good thing, of course, you can see here, here, and here, comparing this, there is no derivative, right? You need not calculate derivative of the function at any point. Okay. So these are the 3 algorithms which we will use for our robotic application. Now let us consider a two-link robot manipulator. Two-link robot manipulator. Say this is x, y. This is my theta 1 value. This is theta 2 value. And say this is my x, y point, and say this is L1 length, this is link length L2. So as you know, equal to L1 cos theta 1 plus L2 cos theta 1 plus theta 2, and y equals to L1 sin theta 1 plus L2 sin theta 1 plus theta 2. Actually, cos theta 1, as you know, is actually cos theta 1, okay? And cos theta 1 2 equal to cos theta 1 plus theta 2, and same is the case for sine. Okay. So these are the equations. Okay, for solving inverse kinematics, this will be given, and I need to figure out theta 1 and theta 2. This we have done, of course. This is the example I have taken. This can be solved, of course, in terms of 8 and 2 function, which we have already done in my earlier classes. But today we will not do that. Okay, so we are going to use these three algorithms to find, for given xy, to find theta 1 and theta 2. So as you can see, this is a function. So this is function 1, we are calling function 1, which is a function of theta 1 and theta 2. So that is equals to L1 cos theta 1 plus L2 cos theta 1 plus theta 2 minus x equal to 0. So you need to do this. So I am taking here and I am calling this function, naming this function f1. Similarly, I have another function. So L1 sine theta 1 plus L2 sine theta 1 plus theta 2 minus y equal to 0. So these are the I have multiple. This is an example of multiple functions, two functions. It could be n, but for six-linked robot manipulator, the function will be 6. 7-link manipulator like Baxter, it will be 7. And in case of now robot, the function will be 5. If it is hand, if it is leg, it will be 6. If it is head, it will be 2. All kind of thing, you know. So it's general. Yeah. So this can act as an illustrative example. That's why I have taken this. Now what you'll have to do, we'll have to figure out, because to use these algorithms, what I need to figure out the Jacobian and Hessian matrix, right? So what will be the Jacobian of this function of several variables? So Jacobian matrix of the function fi, where I equals to 1 and 2, Jacobian of this function is actually first order derivative, and differentiate. So this you will have to do with respect to theta 1, and then same function you will have to differentiate with respect to theta 2, and same function we'll have to differentiate with respect to, the other function, to differentiate with respect to theta 1 once and theta 2. Okay, so two link manipulator, two variables theta 1, theta 2, it will be 2 cross 2 matrix, and this you will have to find out from 1 and 2. So this, I am not writing theta 1 and theta 2. You understand. So minus L1 sine theta 1 minus L2 sine theta 1 plus theta 2, right? You are differentiating with respect to first theta 1, then this will be the case. Then the same function you have to differentiate with respect to the other variable theta 2. So then it will be 0 minus L sine theta 1 plus theta 2. So I am not jumping any steps so that you can just know. Then other function, so you'll have to do that. Now come on here. So L1 cos theta 1 plus L2 cos theta 1 plus theta 2. Okay. And this is constant because Ax and Y will be given to you, right? We are solving inverse kinematics problem. Please do not forget. theta 2 will be equal to so do not forget, sorry about that, you have to differentiate this second function with respect to theta 2. So L1, so this is becoming 0 plus L2 cos theta 1 plus theta 2, right? So if I mistake, you can now, because you know the mechanism, you can do 2 by 2 link, 7 by 7, 6 by 6, 5 by 5, everything you can do, you will have to do exactly the same way I am doing it, okay? So, and now once you have got, so put it here, and you got the Jacobian matrix. So minus L1 sin theta 1 minus L2 sin theta 1 plus theta 2 first element, second element will be minus L2, right? This doesn't matter. You can even think of making, because we are learning how to run, how to apply those algorithms. Okay, L1 equal to L2 equal to 1, you can assume, no problem. We are not solving the real problem, we are understanding the methods, right? So now you see here L1 cos theta 1 plus L2 cos theta 1 plus theta 2. So second row first column element, and then second row second column L2 cos theta 1 plus theta 2. Okay, so this is our 2 cross 2 Jacobian matrix. Okay, and then you will have to calculate Hessian matrix. Okay, and you know, in calculating Hessian matrix, we know that Hessian, for example, of function of Hessian of function 1. So that will be, you know, this one theta 1 dot, I am writing theta 1 dot square, not theta 1 dot and theta 1 dot, theta 1 into theta 1, no, for simplicity, you understand, huh? So this is theta 1 dot theta 2, right? Similarly, function f1, right? So this is the function. So I am writing f1 and omitting theta 1, theta 2, no problem, you understand, right? So theta 2 dot theta 1 and del f divided by theta 2 dot square. So now this is my Hessian matrix 2 cross 2 for f1 function. Similarly, for f2 function also you will be having this exactly same, right? And the other function now, and theta 2 times theta 1 and d to f theta 2 square, right? So this will be another Hessian matrix 2 cross 2. Since here n equals to 2, so this is the Hessian matrix. Now Hessian of the function, say f total, actually if I consider this is in vector form, then you will have to write Hessian for the function for the function 1, then Hessian for the function 2. So this is a tensor. So this is 2 cross 2, this is 2 cross 2. So it will be, you see, 2 cross 4 matrix, tensor actually. Okay, so but we'll have to know how to evaluate them. It is not difficult. So this is the way for two-link manipulator. Once you calculate the Hessian tensor, once you calculate Jacobian, then you can actually run these two algorithms. These two algorithms. Okay, and this also without calculating Jacobian. You see, this is computationally friendly, isn't it? No Jacobian computation, no Hessian matrix. This is only functional values given two guess point, and calculating functional value into those points you can start. So that's it. So I wanted to tell you that how to utilize our concept which we have studied so far. And please go ahead and make your hand dirty now. Means you solve this, apply this. Okay, and for computation you can assume to avoid complexity, L1 equals to L2 equals to 1 unit. Okay, no problem. So they will not be there. L1, L1 will not be there. Okay, so that's it. And you please implement in two-link robot manipulator. We'll also discuss how to implement in the next class, but you can also try now. Okay, what you'll have to do, you'll have to just make guess, right? Initial theta1, theta2. I will give you some values that xy, and then from initial xy, you will have to go there and we'll discuss. But till then, you try to understand all this. If you have any problem, come to the discussion forum. And if not, then stay safe and goodbye.